Hello and welcome to a video presenting our aircraft spar design. The project's aim is to create an effective spar design that will meet requirements under design constraints. In order to accomplish this, we broke our design plan into 4 different stages. For stage 1, we took use of an initial sketch which was made using research done. What we concluded was that I-beams and H-beams are very functional for structural builds, especially in comparison to a rectangular beam with no internal structures. Removing material not only reduces mass but spreads the load of stress concentrations evenly. Stage 2 included the use of an Excel document, which brought the design ideas into fruition. Using the values in the briefing document, we were able to compute dimensions and also values for calculated bending moments and wingtip deflections. By altering spar cross-section dimensions, we were able to find the lightest beam to pass direct stress and torsional compliance evaluations. We then moved on to SolidWorks. In SolidWorks, we deduced that the cross-section of the spar in a double I-shape demonstrated improved stiffness and bared a greater load of force for it to fracture compared to the other shapes that were tested. These included a single I-shape and a normal basic rectangular beam. Since double I-beams distribute the weight evenly, and they also prevent higher levels of tension to proceed through the web. As well as this, they have a larger moment of inertia, which counts as buckling. The way that we constructed this beam was by using a sheet of foam, cutting it into sections, which the sections were then rolled so that they would bend rather than gluing them together, keeping it as one sheet, and then they were then formed into a beam with a large overlap which allowed for us to use it in adhesive purposes, which is shown in the figures below. For our final stage, we built the designs that we tested prior in Excel and SolidWorks. The designs that we built included the single I-beam and also the double I-beam. We also built the standard rectangular beam, which we then load tested. We did this by connecting it to a vise and adding weight and seeing at which point each beam would fracture. We then solidified our case that the double I-beam was the strongest and most suitable for use as a spar. To conclude, the project as a whole went well. It could have been improved, however, through use of more iterations, which brings us to the approach that we took. It was an iterative approach. We tested each design, built it, and saw it failed. When it failed, we saw how we could improve this, and this included the amendments that benefited our design. We moved from a single I-beam to a double I-beam because we felt like it would be more structurally sound. Other than that, we are quite happy and we hope you enjoy this video.